Hello there, Year 9s, Mr. Herman here, and this is exercise 5I, solving quadratic equations using the quadratic formula. Or on the log sheet, it should just say the quadratic formula. Learning goals for this lesson is to know the quadratic formula and when to apply it, and to know what the discriminant and what it can be used for. The success criteria for this lesson is to be able to use the quadratic formula to solve a quadratic equation, and to be able to use the discriminant to determine the number of solutions of a quadratic equation. Now, traditionally speaking, when we approach or attempt the last exercise of a topic, generally speaking, it's the hardest topic. It's the trickiest one that we face. We apply all the skills that we learned from all the previous exercises, and then attempt questions that cover different key knowledges or skills or success criteria. The thing about this topic is, and it says it within the title, we're solving quadratic equations using the quadratic formula, and the key word here is formula. Now, hopefully by now you should know that if a formula has been provided to you, we just simply use the formula to solve for something. We don't have to apply some what seems to be at the times arbitrary rules to get an answer and do a trial and error type of method to get an answer. Here, ironically speaking, it's the last topic, but here we're just given a formula and obtain information for that formula to get an answer. So what we're doing is we're solving quadratic equations. So at this point right now, you should know that a quadratic formula takes on the standard of ax squared plus bx plus c being equal to 0. So there's our quadratic equation right here. Now obviously the things that will be replaced, a, b, and c. Sometimes this will be a non-zero answer. You would just take that onto the other side or add or subtract whatever it is, so you force it to be 0. But this is a general format of a quadratic equation. And then there's different methods that we can use, completing the square, testing to see if a is equal to 1, then we find two numbers, and when multiplied will give me c, but then when added will give me b. All the previous exercises, there are different approaches. Here we've got this nice formula called the quadratic formula that we can use. In other words, I'm not going to write this down now because I'm going to scroll it down to show you what it looks like. But in essence, what we will do is we're going to solve x by using a formula. X is equal to, you input the a, the b, and the c value, whatever these are, into a nice little formula, and it will spit out either 0, 1, or 2 solutions. Now the formula I'm going to show you is at the bottom. You're just going to make sure that a within the scenario is greater than 0, or a is less than 0. Okay, so a is greater than 0 or a is less than 0. You can't have the scenario where a is equal to 0, because if a is equal to 0, this will imply that 0 times x squared will give me 0, so it will just be a bx plus c, which isn't necessarily a quadratic, because the highest power won't be 2 anymore, it will be 1. Okay, so you're just going to make sure that your a is greater than 0 or your a is less than 0. B and c can be 0, because the highest power of 2 will still remain within the x, but it has to be greater than 0 or less than 0. So what is this formula? Now I'm not going to show you how the formula came about. I'm not going to show you how to get the formula. I'm just going to show you the formula as it is. It might seem a bit intimidating at first, but this quadratic formula is right here. So if ax squared plus bx plus c is equal to plus c is equal to 0, where a, b, and c are constants, since a doesn't equal to 0, then to get x, this is your quadratic formula here. And you will potentially, and I say potentially because it depends on what type of scenario we get under this square root, but potentially there are two solutions: minus b minus the square root of b squared minus 4ac within the square root all over 2a, or minus b plus the square root of b squared minus 4ac all over 2a. You will see this shorthand notation here where they put the plus and the minus together. Now you look at this and you think, whoa, these are really, really big formulas. But in essence, if you can tell me what A, B, and C is, you just simply plug these numbers into the formula. Every single letter will be replaced with a number, and then you can just solve. It will spit out, potentially, I say potentially several times, it will potentially give you a numerical answer of some sort. And it will give you 2. And this is just based on the fact that because there's a square root here, you can get 2 solutions, one with a minus and one with a plus. This just sprouts from the fact that, put it very simply, if I were to get the square root of 4, the square root of 4 can either be negative 2 or 2, because negative 2 times negative 2 can give me 4, and 2 times 2 will give me 4. So anything with a square root involved will spit out 2 different solutions. That's why that plus and minus is there. So this is called the quadratic formula. Now the quadratic formula, this is useful when a quadratic cannot be factorized easily. In fact, even if a quadratic formula can be factorized easily, it's still pretty cool to use this handy formula, because all you got to give me is A, B, and C, and it can just be spat right into here. Now, within this quadratic formula, there is a thing called a discriminant, and it's dictated by this little small triangle. This here is a Greek symbol known as delta, or the letter D. So the discriminant, they've just used, discriminant starts with the letter D here. The discriminant is the b squared minus 4ac, and you can see this, it's in both of them. It's the 2 sets of terms that's within the square root. So this little thing within here is called discriminant, and there are 3 different scenarios that you can get with your discriminant. So say for instance you get your quadratic formula, you plug in your numbers, and specifically you plug in your b, you square it, and you subtract 4 times a times c. Now when that discriminant is less than 0, the quadratic equation has 0 real solutions. Okay, that has 0 real solutions. There's no way that we can solve for x. And this is because of the fact that if this number is less than 0, you get into a scenario where you're trying to find out the square root of a negative number, which doesn't suffice. You cannot find the square root of negative 1. There are no true numbers that when you multiply, no real numbers I should say, no real numbers that when you multiply together will give you the answer negative 1. It can't be 1 because 1 times 1 gives me positive 1, and it can't be negative 1 because negative 1 times negative 1 gives me positive 1 as well. So there's no two real numbers, and when you get into the scenario when your discriminant becomes a negative number, so negative 1, negative 5, negative 8, doesn't matter, there are 0 solutions. This becomes undefined. When the discriminant is equal to 0, so you will get a scenario when you plug in your b and your a and your c and you work this out and you get a 0. The square root of 0 is 0. When that is the case, you will only get one real solution. You will only get one real solution. This will be minus b all over 2a, because you will either be minusing or plussing a 0. So that will just be your answer, and there will only be one solution. When your discriminant is greater than 0, the quadratic equation has 2 real solutions, just as you would suspect, and you would just go ahead and simply plug in your a, b, and your c to get your 2 solutions. So this is why I said potentially. It really depends on what your discriminant is. Let's have a look at a few examples to see how we can apply this discriminant logic and then also use it within trying to find what our solutions will be. Alright, here we go. Example 20. Using the discriminant. We're going to determine the number of solutions to the following quadratic equations using the discriminant. So remember, the discriminant, which is dictated by this triangle here, is equal to b squared minus 4ac. So the first example, x squared plus 5x minus 3 is equal to 0. Now I always get into the habit of writing what my a is equal to, what my b is equal to, and what my c is equal to. And this is just the coefficients in front of the x squared, the x, and the constant as well, respectively. So the coefficient in front of the x squared is 1. Okay, don't put it as 0 because it's not 0. There's an invisible 1 if it's by itself, or there's one lot of x squared, so it's 1. For b, this is 5. And for c, this is negative 3. Remember, it's a negative because constant has a negative in front of it, so it's negative 3. So we just go ahead and simply plug in b squared, which is 5 squared minus 4 times a, 1 times c, which is negative 3. Now just be careful with your signs because there's quite a few signs going on. Let's just make sure that we know that what turns into a positive and what turns into a negative, if that's the case. 5 squared is just 25 minus 4 times 1 times negative 3. So negative 4 times 1 gives me negative 4. Negative 4 times negative 3 gives me positive 12. And so 25 plus 12 will give me 37. So because this answer is greater than 0, so you will say, therefore, as discriminant is greater than 0, there are 2 real solutions. There are 2 real solutions. Okay, we don't know what those real solutions are because we're not exactly using the quadratic formula for this question. It's just asking determine the number of solutions for the following quadratic equations using discriminant. So if I wanted to know what those specific solutions are, I would then use a quadratic formula, but for now we're just using the discriminant. Okay, for b, b was, let's go back up, 2x squared minus 3x plus 4. 2x squared minus 3x plus 4. Let's make sure I got that down. Yeah, minus 3x plus 4, and this is equal to 0. Alright, let's get our a value, let's get our b value, and let's get our c value. Coefficients 2, negative 3, and 4. Remember, it is b squared minus 4ac as our discriminant. So, discriminant is equal to b squared, so negative 3 squared. I've put the negative 3 in brackets to indicate that that negative is also being included. Whenever you get the first part within the discriminant, this part will always be positive. You will either be scoring a negative or a positive number, and that will always result with this part specifically being a positive. This is minus 4 times a times c. Okay, now I'm doing a sneaky by putting an equal sign within the same line. I know you're not allowed to do this, but I'm running out of space. Negative 3 squared will give me 9. Negative 4 times 2 times negative 4. So negative 4 times 2 gives me negative 8, and negative 8 times a positive 4 gives me 8, 6, 24, 32. So this is 9 minus 32, and this here will give me a negative answer because we've got a positive number. We've got a smaller number taking away a greater number. So 9 take away 32. This will give me 10, 11, 22, 32, negative 23. If my math is correct, yep. Negative 23. All right. So therefore, our discriminant is less than 0. Discriminant is less than 0. So therefore, discriminant is less than 0. Therefore, no real solutions. Or in other words, that quadratic formula that we have here, there is no x value that you can plug into this formula that will give me the answer of 0. Okay, that's what this is saying using the discriminant. So I can't give you an x value that when plugged in, both negative or positive, it doesn't matter. Or if I decimal fraction, it does not matter. There's nothing that we can put within here that will make this equal to 0. Okay, we'll see. We've got x squared plus 6x plus 9. X squared plus 6x plus 9. Now, automatically I know this has only got one solution because I know this is such a common quadratic. Two numbers when multiplied to give you 9 and added will give you 6. Both of them will be 3, so there's only one solution. But let's test out this discriminant to double check. B squared minus 4 8c. My a value, b value, and my c value. So a is equal to 1, b is equal to 6, c is equal to 9. So discriminant is 6 squared minus 4 times 1 times 9. So this here will give me 36 minus 4 times 1, which is 4, times 9, which is 36, which is equal to 0. And when it's 0, its discriminant is equal to 0. Only one real solution. Only one real solution. And that solution is namely 3. Minus 3, sorry. Minus 3 is the only one. And that's equal to 0. So to know how many solutions there are using the discriminant is quite simple. You just plug in your A, B, and C. And quite similarly to the actual formula itself, when you get questions like these, find the exact solutions for the following quadratic formulas, you're going to use your quadratic formula and you're going to get potentially 2 solutions, or 1 solution, depending on what the quadratic actually is. So let's go ahead and solve for these ones. We have x squared plus 5x plus 3. My A, my B, and my C. I'm recording this very late at night. It's nearly 10 o'clock, so sorry if my accent gets weird or loopy. A equal to 1, B equal to 5, C is equal to 3. Okay, what's our quadratic formula? So if you want to backtrack back to here, this right here was our quadratic formula. X is equal to minus b minus square root of b squared minus 4ac all over 2a. This formula, as long or as intimidating as it is, this will become second nature. You will memorize this and you'll see this quite a lot if you're going to take the specialist maths course next year, or maths methods in year 11, depending on what trajectory you take. You will remember this at the back of your head. So x is equal to minus b plus minus square root of b squared minus 4ac all over 2a. Give me a, b, and c. I will plug that into the formula and I can solve for what this x value will be to make this equal to 0. So x is equal to minus b, so minus 5 plus minus the square root of b squared, 5 squared minus 4ac all over 2a. Now I've put these numbers in brackets, as you can see in my discriminant as well, because it just makes it easier to know that when there's a number next to another number in bracket, it has to be multiplied. And I do that mostly because you will get negatives involved. So it's good to just keep the negatives together, so you can see if it's a negative times a positive, etc, etc. So I just keep them in bracket. Let's see what this ends up being. So negative 5 plus minus the square root of 25 minus 4 times 1 times 3, that'll be for a minus 12 all over 2. Okay, let's keep going. I can work out the 25 minus 12, so this is minus 5 plus minus the square root of 13 all over 2. Now the square root of 13, 13 is a prime number, so it can't be factorized down any further. So this right here is our final solution. It isn't the most neatest, mathematically speaking, solution, but it is a solution nonetheless. So therefore, now how you write this, you can write it in two ways. You can write therefore x is equal to, and just write this, or you can write the two plausible solutions, or you can say x is equal to minus 5 plus the square root of 13 over 2, and then comma minus 5 minus the square root of 13 over 2. So you're indicating to the reader that there are two plausible solutions, one's a plus and one's minus, or you can write it as the plus minus square root of 13. I tend to write it like this within the beginning years when you first get introduced to the quadratic formula, so you can say, oh yep, there are two solutions, because some people might read this not being familiar with it, even though we know what it means. They might not be familiar with it, and it can get a bit confusing. So if you want to stick to writing the solution like this, that's fine, or like this is fine. Either way, or however you interpret it, the best way or the easiest way, totally up to you. If you were to give that a solution, both of them will suffice. And that is the solution. So in other words, if you were to plug this into that formula, the one that we initially started with, those are the only two numbers that when you plug in will give you the solution 0. Not the best solution because of that sir, but regardless, doesn't matter. Got your solutions. Okay, and the second one, 2x squared minus 2x minus 1. Alright, so I've just written it up here. A, B, and C. A is equal to 2, B is equal to negative 2, and C is equal to negative 1. So I've got the quadratic formula here. X is equal to negative 2. So remember, B is a negative number, and we've already got a negative in front. So I know this is going to turn into a positive 2. But to indicate that this will turn into a positive 2, I'm writing the negative in front of a negative 2. Plus minus the square root of negative 2 squared minus 4ac all over 2a. So all I've done is simply replace the letters with the numbers that I do have, or the variables rather. Alright, let's get this further down. I'm just going to put a line there to indicate that was the previous one. So negative 2 is 2 plus minus the square root of negative 2 squared will give me 4. That part will always be a positive. Minus 4 times 2 times negative 1, so this will be plus 8. 4 times 2 is 8, so negative 4 times 2 is negative 8 times the negative 1, so positive 8 all over 4. Okay, so this will give me 2 plus minus root 12 all over 4. The root 12 can be written as the square root of 4 times the square root of 3. So this will be 2 plus minus so square root of 4, which is 2 root 3 all over 4. And this can keep going further down. I'm running out of room. So just kind of written this on the side here. A new page. Now people will get to this point and they think, yep, this is the final solution. I can't break this square root of 3 any further down. But what you can do is these two, even though there is a plus minus here, it doesn't matter. The 2 is a common factor between this term here and this term here. So I can write this as 2 bracket 1 plus minus 1 root 3, which is just root 3 all over 4. And the reason I've done this is because I can cancel these two out to become 1 and 2 respectively. So this will just be 1 plus minus root 3 all over 2. So being as though that you guys are in SEAL, it should be apparent that there is a common factor within these terms up the top. And the reason why we do that is because we can simplify that down with a 4 over here. If this number was a 5, even though these 2 up top will be 2 and 2, if this was a 5, there's no point taking that 2 as a common factor. But because that 2 as a common factor can also be simplified down because of that 4, because of the denominator, you'll go ahead and do it. So our plausible solution is this here, or you can write it as x is equal to 1 plus root 3 on 2, comma 1 minus root 3 on 2. And there's again solutions for the previous answer or previous quadratic question. That makes sense. So that's it. That is it that we need to do for solving quadratics using quadratic formula. Oh my goodness, it's a weird keyboard. There we go. So the questions you need to do within the weekly planner is question 2 left hand side, question 3 2 left hand side columns, and question 4 2 left hand side columns, and your extension can be question 9. We're going to be doing this for the first 2 lessons, and in the next 2 lessons we'll be looking into doing a practice test with some revision questions. Best of luck, guys. If you have any questions, you know where I am. Ciao.